Sasikan students, let's discuss law of conservation of momentum. Well, we know very well momentum P is a product of mass and velocity. Now, let's understand this law by imagining a situation where we have a mass, a body of mass ma moving with initial velocity ua. It's moving in the same direction of some other body which is having mass mb moving with velocity ub. We want this body to strike this. That's possible only when ua is greater than ub. So that with time this will strike the second body. Now students, what happens? After some time the impact happens. Means both the bodies they strike with each other. Now what happens? Let's assume that they strike with each other, which is known as impact, for a very less time t, for a fraction of time t. In this is body A, this is body B. Body A applies a force F AB on the second body according to third law of motion. Action and reaction are simultaneously happening and they are opposite in the direction and equal in magnitude. So body B will also apply equal force on body A, right? As these forces are in opposite direction. All right?
Yes.
So students, now this force is equal to this force in magnitude but in opposite direction. After the impact, let's assume body A is moving with some other velocity, final velocity VA, and body B also moves with some velocity VB. This is the final velocity of body. You see, both these velocities most probably would be different from the initial velocities of the bodies. Now, let us apply the third law. Third law says the action is equal and opposite to reaction. That means, what is the action? FAB. And that is equal to what? FBA. But because FBA is in this direction, to make its direction in this direction only, we should apply minus sign here.
Minus.
You understood why I applied minus sign? Because this force is in this direction, right? Two vectors are said to be equal if they have same direction and they are same in magnitude. Let's say this is 10 Newton, this is 10 Newton. Now you can say they are equal. All right. So FAB is equal to minus FB. Now according to second law of motion, force is equal to mass into, tell me students? Acceleration. Very good. This impact happened for time t. Now what is FAB? Force applied by body A on body B. This force is equal to mass of body A into acceleration of body A. Am I right? What is the acceleration? Final velocity of body A. What is final velocity? VA minus initial velocity of body A, UA. This change from UA to VA happened in how much time? Time of impact, T time. Am I right, students? So this will be equal to minus of what? The other force. Force applied by body B on body A. That would be equal to mass of body B into acceleration of body B. What is acceleration of body B? Final velocity VB minus, tell me students? VB minus
UB
UB divided by the time.
T
That is
time
T.
of
Very good. So I can say, students, this is equal to T will cancel with T, and I will get MABA minus MAUA is equal to minus MBVB minus into minus plus MBUB. Am I right, students? Now, you see, I will collect initial momentum on one side and final momentum on other side. So I can have MBUB, and this minus goes there, MAUA. I can say MAUA plus MBUB is equal to, this will go to that side, MBVB. So it will be MAVA plus MBVB. See, students, we are having a beautiful equation. A beautiful equation. Let's try to understand its meaning. Students, what is MAUA? This is the momentum of the body A before impact. Am I right? What is MBVB? Momentum of the body B before impact. So I can say, students, that this total is the momentum before impact, right? And what is this? MAVA is the momentum of the body after impact, because VA is the final velocity. VB is the final velocity of second body. This is momentum after impact. This law that the total momentum of number of bodies which are having impact, the total momentum before the impact of all the bodies of the system, you can say, system of bodies, is equal to total momentum after the impact. It can be like this also, students. One body is going in this direction, one body going in this direction, and another body going in this direction. It can be a system of three bodies, MA, MB, MC, UA, UB, UC. After both strike for time t, they will all head into different directions with different momentum depending upon their final velocity, VA, VB, and VC. So in this case, MAUA plus MBUB plus MCUC would be equal to, can anyone tell? MAVA plus MBVB plus MCBC. So total momentum before the impact is equal to total momentum after the impact. Students, what is the application of this law? Let us see. You see, students, we are having a numerical. The numerical is, there's a girl of mass 40 kg. Okay? She jumps with the horizontal velocity of 5 meters per second into a stationary cart. Stationary cart means it's like this. You know, she wants to, you know, she's here initially. She is moving with how much velocity? Her mass is 40 kg, right? She's moving with a velocity 5 meters per second. This is initial velocity u of the girl. Now a girl of mass 40 kg jumps on a horizon with a horizontal velocity this into stationary cart. Now students, before jumping, this is the velocity of the cart. You see, what is the initial velocity of cart before impact? Before the girl strikes on this, what is the velocity of this cart?
0 meter per second.
0. Beautiful.
0 meter per second.
Yeah, it's not moving. But as the girl comes on this, now this becomes a system. Initially, the system was the girl plus cart. But after the impact, the girl and the cart together becomes a system, because the girl is not to get over the get off the cart. She's there on the cart, and the cart starts moving with some velocity. Now, The question is the mass of the cart is 3 kg. The cart mass MC is 3 kg. What is her velocity as the cart starts moving? You see that this question couldn't have been done if you don't know law of conservation of momentum. Now it says what is the velocity of cart? Now students, actually the velocity of cart and velocity of girl after the impact is same because the velocity of the girl relative to cart is zero. Both are moving. It's like we are in a bus. Bus is moving. We are also moving. I explained you in the last video. Our velocity with respect to bus is zero. Now, how can we do this? Now, same. We will apply conservation of momentum. What does it says? Total momentum before the impact is equal to total momentum after the impact. Now students, before the impact, what is the momentum of the girl? Mass into velocity. What is the mass of girl? 40. What was her velocity before the impact?
5 meters per second.
5. Correct.
5.
Now, what is the mass of the stationary cart? 3 kg. But what is the velocity of cart before the impact? 0.
0 meter per second.
This total momentum should be equal to, now girl and cart are same. So what is the total mass after the impact? We have to take the mass of girl as well as mass of cart. So that will be
43.
40 plus 3. But we don't know velocity. With which velocity it will move. We can find out. This is 45 by 43 would be equal to velocity of cart or velocity of girl. So that will be 1
Sir,
point.
that's 200
How much?
by 43. 200 by
I'm
43.
sorry. This is 200 divided by 43. So you could find out approximately equal to 5 meter per second would be the velocity of the girl. Is it interesting, students? So to see more videos like that, log on to our channel, Learn CBSE. We have videos of 9th and 10th physics and maths both there. Thank you.